Hello everybody. Today I am going to discussing about first chapter from SSC, that is heat chapter. Very important chapter. So not only for SSC students, and these basics are useful in your intermediate. Is a very important thermodynamics chapter. So there we will use these basics which you all learned from this chapter. That's right. Listen carefully, students. Okay. So before going to our chapter, we will discuss about some important points. What is heat and what is temperature? Generally, we use this heat and temperature words for same purpose in our general daily life. Is it same really? No. So heat is different and temperature is different. So the things we discuss here, what is heat and definition of heat and what are the units of heat and then what is temperature and what are the units of temperature. With all these things, we'll discuss some more things about what is thermal equilibrium, then what is method of mixtures, specific heat of lead Schwarz experiment, then applications of specific heat. After that, we'll discuss about some important concepts like evaporation, okay, boiling point, melting point, freezing point, humidity, fog. So all these things, latent heat of evaporation, latent heat of fusion, all these things we discuss with some applications also. So before, okay, we will go to discuss about what is heat. So heat is a form of energy and it transforms from high temperature body to cool temperature body or low temperature body. So then how do we differentiate with the heat and temperature? If suppose, so if we take any water bottle or anything, any plastic or any liquid, if you put it in a refrigerator, after some time you take it out, if you touch it, you feel it is cool. Okay, if you put iron rod, any metal rod, if you put it on a lamp or on the flame of any heater like that, if you put that, if you touch that one, you feel it is very hot. We take it out our fingers. So in the first case, the refrigerator case, we feel it is cool. In the second case, if you put it on the flame, you feel it is hot. In the second case, it is hot. What is this cool and what is this hot? Why we feel cool and why we feel it is hot? In the first case, in the refrigerator case, okay, the temperature of object which you put in the refrigerator, so the temperature will goes down like 0 degrees like that. Our body temperature we already know that 36 degrees. So we already discussed the definition of the heat. Heat transform from high temperature body to low temperature body. That means temperature of a human body like us, so very high than compared to the object which is taken out from the refrigerator. That's right. Temperature will goes from our body to that object which is put it in the fridge. That's where we feel cool because we lost our temperature, we lost our heat, we lost our energy. That's why we feel it is cool. The second case, if you touch any hot iron rod, you feel it is hot because the temperature of that iron rod is more than the temperature of our human body. That's why that the temperature transforms from hotter body like iron object to our body. That's why we feel it is hot. So in this case, we understood that how temperature transform from how heat transform from hotter body to colder body. That is called heat. Then what are the units of heat? is heat is a scalar quantity or a vector quantity? First of all, we define heat. What is heat? So heat is a form of energy. Heat is a form of energy and it transfer from high temperature body to low temperature body. This is the definition for the heat. So what is heat? Heat is a form of energy and it transfer from high temperature body to cool temperature body. So what are the heat is a scalar quantity or vector quantity? Clearly heat is a scalar quantity because it have only magnitude. It have only magnitude. Then what are the units of heat? There are two types of units we have. One is generally nowadays all we are all following SI units. Before this SI units we have CGS units. In CGS units, units of heat in CGS is calorie. So what are the SI units of heat is joules. Is there any relationship between calorie and joule? It's very very important. One mark question for SST students. What is the relationship between heat and CGS unit of calorie and SI unit of joule? Yes, 1 calorie is equal to when 1 calorie is equal to 4.186 joules, or simply we can write as 4.2 joules approximately. So 1 calorie is equal to how much we can write? 4.2 joules. So we understood that what is heat and definition of heat, and it is a scalar quantity, and SI units are joules, CGS units are calorie. 1 calorie is equal to 4.2 joules approximately. Now we are going to define temperature. What is temperature? So temperature is a degree of coolness or hotness of a body. So what is temperature? Is a degree of hotness or coolness of a body. That means it is a measurement of heat. Simply we can write temperature is a measurement of heat. How do we measure heat? So temperature is a degree of hotness, how much heat it is. Suppose what is the heat means how many degrees of temperature we have. 10 degrees, 20 degrees, 30 degrees, 5 degrees, 10 Kelvin, 5 Kelvin, 200 Kelvin, 300 Kelvin, like that. So is it a scale? Temperature is a scalar quantity or vector quantity? We can write it is a scalar quantity. Again, scalar quantity. Temperature is a scalar quantity. That's why we have only what? Magnitude. Then units. We have different units for temperature. To measure the temperature, we have different units. One is Celsius. Second one is Fahrenheit. Third one is Kelvin. These are the different units. This Celsius and Fahrenheit is Celsius units, and this one is SI unit. So what is the SI unit of temperature? Kelvins. Okay, now is there any relationship between Celsius and Fahrenheit and Kelvin? Yes, so we have relationship between Celsius scale that is called the thermometry. So measuring of temperature with the different scales is called thermometry. Thermo means a heat, so metry means a scale. Thermometry we have three types of thermometry. One is Celsius scale. This one Celsius scale. Second one is Fahrenheit scale. Third one Kelvin scale. How do we define this Celsius scale, Fahrenheit scale, and Kelvin scale? All these things in your intermediate actually. So if you know now, it is better for better understanding in your next class, intermediate first year. Okay. So what is Celsius scale? How do we define a scale? Now we already know that meter scale and so 50 centimeter scale, 30 centimeter, 30 meter scale, 30 centimeter scale. Like that, we have different scales. So how do we define a scale? Suppose it is 50 centimeter scale. Initial point and final point we have. The initial point is 0, final point is 15. In 30 centimeter scale, initial point is 0, 30 centimeters is the final point. There are two fixed points. For every scale, there is two fixed points. In the same manner, we have Celsius scale. For what are the two fixed points for Celsius scale? So scientists consider that for fixing the fixed points, they have taken water. So what is the freezing point of water? So freezing point of water is that is called freezing point of water. That is also called lower fixed point, and that is starting point of the Celsius scale. Lower fixed point, that is 0 degrees. We are going to define Celsius scale here. Celsius scale. Freezing point of water is lower fixed point, is equal to 0 degrees centigrade, and boiling point of water. Boiling point of water, that is upper fixed point, UFP, that is 100 degrees centigrade. Water boils at 100 degrees, that is called UFP. These are the fixed point, lower fixed point and upper fixed point. This scale, what is the difference between these two scales? 100 degrees centigrade. Difference is 100 degrees centigrade. So this 100 degrees centigrade is divided into 100 equal parts. How many equal parts? 100 equal parts. That means the scale is divided into 1 degree. So like this, 1 centimeter, 2 centimeter, 3 centimeter, like that, how we divide. 0 to 15 means 15 equal parts. Like that, Celsius scale is divided into 100 equal degrees. 100 degrees, 100 equal degrees. So this is all about the Celsius scale. Second one is Fahrenheit scale. Here also freezing point of water only we have taken, but in Fahrenheit that is freezing point, or LFP, is equal to 32 degrees Fahrenheit. That is a lower fixed point. So freezing point of water, lower 32 Fahrenheit. That is a boiling point of water, that is a UFP, that is equal to 212 degrees Fahrenheit. Again, difference is 180 degrees Fahrenheit. That means Fahrenheit scale is divided into 180 equal parts. That means 1 degree Fahrenheit. Each one is 1 degree Fahrenheit. So this is all about Fahrenheit scale. So then after that we have Kelvin scale. So Kelvin scale, that means in Kelvin scale, freezing point or of water LFP is equal to 273 Kelvin. That means 0 degree centigrade is equal to how many kelvins? 273 kelvins. See, LFP 0 degree centigrade. Here LFP is 273 kelvins. That means we can equate 0 degree centigrade is equal to how much we can write? Kelvins, 273 kelvins. So then upper fixed point or boiling point, upper fixing point UFP, that is equal to 373 kelvins. What is the difference? 100 degrees kelvins. 100 degrees Kelvin. That means this scale is divided into 100 equal parts. So each part is 1 degree Kelvin. Okay. So in this way, we defined 3 scales for measuring the temperature. We have a beautiful measurement for measuring the temperature. We have Fahrenheit scale for fever and all these things in our daily life. We use the thermometer. So like this, these are also different thermometers. These are also different types of thermometers. This is Fahrenheit. This is thermometer. Fahrenheit scale means thermometer. So Celsius scale is also there and Kelvin scale also there. Okay. Now, so is there any relationship between centigrade scale to Fahrenheit scale to Kelvin scale? Yes, we have a relation. What is the relation between the 3 scales? Very simple. Before going to the given the relation, we will give the formula for each scale. So for each scale, we can define a formula. That means centigrade means we define as C minus. So LFP we will consider C minus LFP, that is 0 degrees. C minus 0. So centigrade scale, that's why we take C minus 0 degrees. LFP is 0 degrees divided by how many equal parts we have taken. What is the difference between the LFP and UFP? That is 100. That's why C minus 0 by 100 is equal to, then free Fahrenheit scale. So you tell that in Fahrenheit scale we represent Fahrenheit scale with F. What is the LFP of Fahrenheit scale? 32. That means F minus 32. So what is the difference between the LFP and UFP? 180 degrees. That means each part is divided into 180 equal parts. That's why each part is 1 degree. That's why the difference is 180 is equal to. For Kelvin scale, it is we represent Kelvin scale with K. What is the LFP? 273 kelvins divided by. What is the difference between the two LFP and UFP? 100. In this way we can define. So we can simplify here only. So all the table is divided with 20, 5 20s, 9 20s and 5. That is equal to C by 5 is equal to F minus 32 by 9 is equal to K minus 273 by 5. In this way we can define the 3 scales. We can relate the 3 scales. So we already knew that 0 degree centigrade is equal to how many kelvins? 273 kelvins. We can simple. We need not to do all these things. If you know this 0 degree centigrade, 273 kelvins, if suppose if you ask what is 100 degrees centigrade in kelvins, that is 100 degrees centigrade means you need to add this 100 to 273. That means 100 plus 273, that is equal to 373 kelvins. That means if we need to convert Celsius scale to Kelvin scale, you have to add that degrees value with 273. We can easily convert. And another way, if suppose 573 kelvins, what is that? 573 kelvins has given what is the value of degrees? So what is the value in degrees? That is 573 minus, we need to subtract 573 minus because we have given kelvins and we need to convert into degrees. That is, we have to subtract with minus 273. And if suppose degree Celsius to convert into kelvins means you have to add with 273. So 0 0 300 degrees centigrade. 573 kelvins means what? 300 degrees centigrade. By this way we can convert. So degree Celsius to kelvins. If suppose if you are asked to convert for centigrade scale to Fahrenheit scale, so if suppose if you are given 38 degrees, so degree centigrade, convert into Fahrenheit. Convert into Fahrenheit. So how do we convert degree Celsius to Fahrenheit? So we have given C is equal to 30. If you substitute C value here, so 38 by 5 is equal to, we need to convert it into Fahrenheit now. That's why F minus 32 by 9. Here we can cancel it 5 with so 7 5s are 35. We get again 3.30, so 6, 7.6. So we can cross multiply this 7.6 into 9 is equal to F minus 32. F minus 32. If you multiply with 7.6 with 9, 9 6 are 54, 5 4 5 7 9 7 63, 63 plus 5 68. 1 point after you need to put, so one number after 68.4, so 68.4 F minus 32. If you take minus 32, other side of the equal, you get plus 32. 68.4 plus 32 is equal to 48. So we need to add 32. 4 8 plus 2 10, 66 plus 9 100. So that means 100.4 is equal to 48. That means it is favor. Okay, that means if we get 100 degrees Fahrenheit means our body temperature in Celsius is 38. In this way we can convert Celsius scale to Fahrenheit scale, Fahrenheit scale to Celsius scale. Okay, so here we have a beautiful application in our daily life. If suppose in our summer temperature is rising to 43, 44, 45, 46 like that, so how our body to cope up with the temperatures? All we have to suffer with high fevers. You know what is the meaning of high fever? There is 104, 105, 106 means we are not in our conscious state. We may be died. So that means 105, 106 means. Okay, but our body is maintaining or our body is managing all these high temperatures. Even though here we already discussed 38 means 100 degrees centigrade. Suppose our atmosphere temperature is 38, our body temperature is 100, Fahrenheit is 100 Fahrenheit. Means favor. If suppose it's going to 42, 43, 44, it may be crossed to 105, 106, 107. Even though we are not going to die because our body mechanism have been constructed like that. If suppose atmosphere temperature is high, our body temperature is low, then temperature will transfer from hotter body to colder body. That means atmosphere is 43, our body is 38, if suppose 37, suppose that 43 degrees will comes to our body, then our body temperature may be rise. For that our blood, okay, in our blood, okay, our hormones tells us that tells our body to release some water out with our skin. That is called sweat. We will get sultry, we will get sweat. That's why in summer we will get more sweat because to compensate the temperature. So that's why what happens if suppose if our body takes out that water from the as a sweat, so by evaporating our body gets cooled. Evaporation is a cooling process. That the thing also we discuss next. Okay, so by that evaporation our body feels it cool. That's why so our body temperature again comes back with 38, 37 like that. In that way our body manages. In some animals there are no sweat pores to release sweat out, like dogs. That's why they pants in summer. So with take out their tongue outside and they uses that saliva out and they pants like that to overcome that high heat. So with that, the evaporation happens with that they pants out na with that the water will evaporate that makes them feel cool. With that they escape from the dive. So this is all a natural process. Okay, so every organism which have its own natural process to overcome the atmosphere. Okay, now that is the main application. In the winter also, temperatures will goes down like 20 degrees, somewhere in 5 degrees, minus degrees. At that time also, our body is hard body when compared to atmosphere because atmosphere is 0 degrees centigrade. Our body is 38 degrees, 37 degrees centigrade. We are hotter than the atmosphere. Then we have to radiate heat. We have to give out our heat to that atmosphere. Then our body cools down. Then even though our temperature may not fall down to 36 and 37 degrees centigrade, then what happens? Again, our hormones and our body, our brain tells our body organs, muscles, especially muscles, to work fast, more faster. So that's why in a winter, especially everyone have to do some workout to make our body hot, to do our blood, to supply our blood. To circulate our blood more faster. So that's why we need everybody have to give more workouts. So to compensate with that temperature, cool temperature, that's why you see that elders ages get strokes, heart stroke or brain strokes more at the time of winter season. So in the old age, the ages, so the body may not mean overcome that atmospheric temperature. That's why they maybe die. Okay, so tell about body mechanisms. Okay, these are applications of these things. Okay, now, so we discuss relationship between different thermometries. Okay, after this we are going to discuss about thermal equilibrium. What is thermal equilibrium? Before going to thermal equilibrium, again we have one important point for the SSC examination, 1 mark question. What is absolute temperature? So what is absolute temperature? This is a 1 mark important 1 mark question. What is absolute temperature? The temperature measured in Kelvin scale. Temperature measured on Kelvin scale. The temperature is called absolute temperature. Kelvin temperature is nothing but absolute temperature. This is a very, very important point. You must write it or underline this point. Okay. Next, thermal equilibrium. What is thermal equilibrium? So very, very important concept is again it occurs in our intermediate thermodynamics, first law of thermodynamics. It is first law of thermodynamics simply describe about thermal equilibrium. So then what is thermal equilibrium? So very, very important. If you take a coffee, okay, in the early morning, if you take a coffee with hot coffee, you will get some, okay, smoke comes out. Okay, now if you keep that coffee sometime, okay, in the outside, so after some time it loses. Suppose initially if its temperature is 100 degrees centigrade, after some time it may lose its temperature. At what point it loses its temperature? Until unless it reaches the atmospheric temperature. I told you already what is atmospheric temperature, room temperature. That is generally we consider 36 degrees temperature is called room temperature. That means this coffee will loses its temperature until unless it reaches 36 degrees temperature. Because we contacted this coffee to, we thermal contacted this coffee to atmosphere. That's why it attains the atmospheric temperature. That's 36 degrees temperature. After reaching 36 degrees temperature, is that coffee again loses its temperature? No, because we already discussed earlier definition of heat. Temperature heat is transfer from high temperature body to low temperature body. Once the coffee reaches the 36 degrees temperature, Even coffee is 36 and this one atmosphere is 36 degrees. Both will attain same temperature. That's why there is no transfer of heat. That means at equilibrium state, we can simply tell that at equilibrium state there is no transfer of heat. Then how do we define thermal equilibrium? So if suppose if we are in a room, our body, the things which are in that room are thermally contracted. All know that's why all are in thermal equilibrium. Suppose if you are in a room with chair, bed, table, you and this fan, light, everything in thermal equilibrium. Because all are in thermal contact. Equally, all are contacted with thermally. That's why all are maintain the same temperature. Okay, there is no transfer of heat. That's why we ourselves contacted with thermally contacted with atmosphere. That's why we are not losing our temperature. We are not losing more or losing not more our temperature because we are thermally contacted with atmosphere. Okay, in the same manner, So here also. So now we are going to define thermal equilibrium. If two bodies like A and B, say A and B, are in thermal contact, if two bodies with two different temperatures are in thermal contact, after some time they attain same temperature, then there is no transfer of heat happens. Such process is called thermal equilibrium. That law is called first law of thermodynamics. So what is thermal equilibrium? If two bodies are in thermal contact, whenever there is no transfer of heat happens, such condition is called thermal equilibrium. That process is called, that law is called first law of thermodynamics. Okay, that's all about thermal equilibrium. So after thermal equilibrium, we are going to discuss about what is the relationship between temperature and kinetic energy. Relationship between kinetic energy and temperature. So before going to this kinetic relationship between kinetic and temperature, we will discuss about what is kinetic energy. So the things we have to understand before. So what is kinetic energy? So kinetic motion. If suppose if any object possesses kinetic energy, that means that object is in motion. That is, how can we define? Energy possessed by a body by virtue of its motion. If any object possesses any energy with its motion, that energy is called kinetic energy. Energy possessed by a body by virtue of its motion, movement. By virtue of its movement is called kinetic energy. So what is the formula for kinetic energy? So kinetic energy K is equal to half mv square, where K is called kinetic energy, m is called mass of the object, v is equal to velocity of the object, K is equal to half mv square. That is the formula for kinetic energy. Then what is the other energy? We have that thing also discussed in our earlier class, 9th class. What is potential energy? Energy possessed by a body by virtue of its position or height. If any object attains some energy with its height or position, that energy is called potential energy. So with the height, if a body attains any energy, that energy is called potential energy. Potential energy P is equal to mgh. P means potential energy, m means again mass of the body, g is called gravity. Gravity on the Earth is equal to 9.8 meters per second square. Next, height h is equal to height, because potential energy is nothing but comes with nothing but height. That's why height h is called height of the object which it is placed. So what is a total mechanical energy or mechanical energy? So total mechanical energy is nothing but Ke plus Pe. The sum of potential energy and kinetic energy is called total mechanical energy. So total mechanical energy is nothing but Ke plus Pe. We have another energy here in our class, internal energy. What is internal energy? So internal energy. What is internal energy? This is simply we can write a sum of so linear Ke plus rotational Ke plus vibrational Ke plus potential energy. The sum of all these energies is called internal energy. So we discuss about internal energy in this chapter. We use this concept, internal energy concept, in the earlier concepts. We discuss about the internal energy there. Okay. So what is internal energy? Sum of linear kinetic energy. That means straight line. Suppose if object is moving in straight line, moving means that is it will definitely have a kinetic energy. In a straight line, it is having energy means linear kinetic energy. If object is in rotation, the object attain rotational kinetic energy. The object is vibrating to and from motion. They are also having vibrational kinetic energy. And if suppose the object is in certain height, it also attains potential. Sum of all these things is called internal energy. So this is all about kinetic energy and potential energy. Now we are coming to our relationship between kinetic energy and temperature. This will explain with some activity. That activity is also in your textbook. Very beautiful activity and very easy. Now take 2 beakers with water. Both beakers we take water, but in this beaker we take hot water. In this beaker we take cold water. So we know that in hot water kinetic energy is more. Why? There is a hot water, nothing but already we have given some heat to that water. That means it has taken that water particles will taken that heat. That heat energy is converted into kinetic energy, because with that heat the particles in the water move more speed, move with more speed, move with more velocity. The movement is high when compared to cold water. In cold water the particles also move, but with compared to hot water the movement of particles is low. Because in the hot water is already taken some energy, heat energy has taken, that's why they become hot water. With that heat energy, here that heat energy is converted into kinetic energy. So if suppose if we relate that if you pour some red food colors, food colors like red food color, if you pour into that here in this water and in this water, so where we see the distribution of red in high speed in compared to the hot water and cold water. Obviously the speed of distribution of red food color is high in hot water than in cold water, because in hot water the kinetic energy or the movement of water particles is more when compared to cold water. By that we can conclude that the average kinetic energy of the particles is directly proportional to absolute temperature. So the average kinetic energy of the particles. What is the average kinetic energy of the particles? So Average kinetic energy of the particles means the total, when all of the particles which are moved from one place to another place. If we take the average of the kinetic energy of the particles, is equal to Ke. E is directly proportional. Absolute temperature means temperature which is measured in kelvins, T. So capital T is the absolute temperature. So Ke is directly proportional to absolute temperature. This is the experiment. By the experiment, we can conclude this kinetic energy. What is the relation? Kinetic energy is directly proportional. That means if temperature is high, kinetic energy of the particle is more. If temperature is low, kinetic energy of the particle is less. Okay, we conclude like this. So this is the activity, very important activity. So after this relationship between kinetic energy and absolute temperature, we are going to discuss about specific heat. So what is specific heat? So we'll define specific heat and we'll get some formula for specific heat. So that specific heat concept also we discuss with an activity. First of all, we understand activity, specific heat. What is specific heat? So first of all, if we consider two beakers, again, in one beaker we take 250 grams of water. So mass of the water here is 250 grams. In another beaker, we consider 1 kg of water. These are two beakers with two different volumes of two different masses. Okay, weights of the beakers we can consider here. So if we want to heat them for 60 degrees centigrade, which beaker will take more time for getting 60 degrees centigrade? Obviously, this is 1 kg of water. So with that, we can understand that if suppose change in temperature is constant, if we consider change in temperature is constant, that is 60 degrees centigrade only. If you consider like this only, that means the amount of heat is directly proportional to mass of the water. That means Q means heat is directly proportional to mass. When this happened? When change in temperature delta T is constant. If delta T change in temperature is constant, heat is directly proportional to mass. Because if mass increases, we need to give more heat. Okay, in the same manner, this we call as a first equation. So Q is directly proportional to change in temperature. That means when mass is constant, if we take mass is constant, that means so both the cases, this is also 1 kg, this is also 1 kg. So in both the cases, if you take same mass, that means mass is constant. If you give more heat, the change in temperature also more. The change in temperature also more. If suppose if you give 10 calories, change in temperature is 60 degrees. If you give 20 calories, change in temperature is 120 degrees, like that. It will directly proportional. That's why mass of the, when it happens, mass is constant. When it will happen, delta T is constant. If we consider this equation is the second equation. From these two equations, from 1 and 2 equations, from 1 and 2 equations, we can conclude that Q is directly proportional to M delta T. As already we defined what is Q, what is M, and what is delta T. Delta T means change in temperature. Okay, so Q is directly proportional to M delta T. Here we need to focus more. Now I am removing a proportional and I am giving equal. Then we have to add. We are removing the proportional. We have to add some constant. That constant is S. If we take that constant is S, S into M delta T. What is called S? So S is called proportionality constant. Proportionality constant. So now that proportionality constant, also called as ORR, also called as specific heat of the object. specific heat. Here, what is the object we have taken? Water. That's right. We can write specific heat of water. Otherwise, if we take it like that only, we can write S means specific heat. Specific heat of the object. Which object we take? That's object. Specific heat. Specific heat of the object. So if you take S as the, that as you already also written as Q is equal to ms delta T. If you take S is the subject, if you take S is subject means S is specific heat, S is equal to Q by m delta T. This is the formula for specific heat. Specific heat S is equal to Q by m delta T, where S is called specific heat of the object, Q is called heat that we have given to the object, m is called mass of the object, delta T is the change in temperature. This is the formula for specific heat. Now we got the formula for specific heat. Now we are going to write the units. We got the formula, then we can also easily write the units. So if anywhere, if you want to get units, if you know the formula of that physical quantity, you can easily write that units of the object unit of the physical quantity. You know, S is equal, again I am writing formula, S is equal to Q by m delta. First of all, we write the CGS units. In CGS units, that's I already told you, Q means heat. What is the CGS units of heat? Calorie. That you simply write as cal divided by. So here divided by mass. In CGS unit, what is the mass units? Grams. That's how it as a G. Delta T, change in temperature. This is simply temperature. What are the units in CGS unit? What is temperature units? Celsius, degrees Celsius. Okay, so this thing we can also write as a calorie. Suppose if you write grams minus 1 degrees Celsius. This is the CGS units. What are the SI units of specific heat? SI units. So what are the SI unit of Q? Heat, joule, J, divided by mass, SI unit of mass, kg. Delta T, Kelvin. This thing we can write J kg power minus 1 k power minus 1. These are the SI units of specific heat. So hope you understand specific heat definite derivation and units. Now we are going to define specific heat. Very important. Very easy. So now I am typing out all these things. I hope you can write these things in your notes by stopping this video. Okay. So definition for specific heat. Very simple. I make it very simple. Listen carefully. I told you already, various objects have various specific heats. No two objects have same specific heats. Various objects have various specific heats. Metals have its own. Every metal has its own specific heat. Plastic has one specific heat. Like any element, every element has its own specific heat. Okay, water has its own specific heat. Water specific heat is very high. So we'll discuss again after this. So the definition for specific heat, application of specific heat, where we discuss all these things. So what is specific heat? How do we define specific heat? I told you already, various objects have various specific. How can we distinguish different objects with different specific heat? Very simple definition. Listen carefully. The amount of heat required for unit mass of the object. What is that? The amount of heat required for unit mass of the object to rise temperature 1 degree centigrade is called specific heat of that object. Simple. For suppose if you take this pen, this mass is 1 unit. That means 1 unit means after that you can take, for definition only I have taken 1 unit. 1 gram, 1 kg like that. Suppose if you take 1 unit of mass of this pen, if you want to increase its temperature of pen 1 degree centigrade, how much heat that you have to give into this pen? And it's called specific heat of that pen. Suppose if you take iron rod, so that is 1 unit of iron rod if you taken. The initial temperature is, suppose the initial temperature 36 degrees. If initial temperature of iron rod 36 degrees temperature. If suppose that 36 degrees temperature, 1 unit of mass of the iron rod, that 36 degrees temperature to 37 degrees temperature. That means we are raising the temperature from 36 means 1 degree. And to rise the temperature of the iron rod to 1 degree centigrade, how much heat energy you are given to that iron rod is called its specific heat of iron rod. Very simple. So we can define like this: the amount of heat required for 1 unit mass of the object to rise temperature. The amount of heat required for unit mass of the object to rise temperature as 1 degree centigrade is called specific heat. Is called specific heat. It is denoted with S. Specific heat, that's why S. We already derived formula. S is equal to Q by M delta T. This is the formula for specific heat. This is the formula and this is the definition. Earlier we discussed about the derivation of specific heat. Now we are going to discussing applications of specific heat. In your 10th class, they are given 3 applications of specific heat. That is temperature of how our earth is with a moderate temperature, and second one is how what happens when we put that watermelon in the refrigerator, and what about the stuff in the samosa? Okay, why it is very hot? The stuff in the samosa more than the outer layer of the samosa. All is because of the specific heat. So I told you already, specific heat of water is very, very, very high. Very, very, very high. That's why. So we already know that. So our earth is surrounded with 3 times of water. Okay, our earth is covered with 3/4 of water. If there is no water, we will see the difference. If suppose there is no water at all the heat coming from the sun will straight away radiate on the earth's surface. So by that, the surface of the earth, temperature rises high and high, and that then temperature of the earth will goes to 100 degrees, 200 degrees, 300 degrees, 400 degrees temperatures. Then no organism on this earth will be possible. That's why nature, so supported with 3/4 of water, this earth is filled with 3/4 of water. 3/4 of earth is filled with water only. Specific heat of water is very high. That's why it takes lot of time to raise the temperature of water. So it is that's why it takes a lot of time to raise temperature. That's why land, so remaining 1/4 of the land takes more time to increase the temperature on the land surface. Then it will distribute after the ocean's temperature is rising. They will send these temperatures to all two poles. Suppose equator having the more temperature, then they will distribute because equator is very high, poles are equator is with a very high temperature, poles are with a very low temperature. That's why this temperature slowly goes to poles. That's why this from this suppose if you consider this is the earth and this is the equator. So this equator with more hot, very hot, water is feeling very hot. Now here these are the poles. These two are the poles. Very low temperature. This temperature will flows from hotter body to colder body. That means equator to one north pole and this to the south pole. In this meanwhile, moderate temperatures will be happen in the earth. So see here it is take America like that. All these places are very cool. Here are cool, and from the equator very hot. That's why in US extreme conditions. Some places are very hot, some places are very cool. In the Australia also some places are very hot and some places are very cool. But in India it's a moderate. We don't have much more temperature differences. So average temperature we have. That's why our climate is very good, especially Asian temperature. Where Africa is very hot. That's why there is pygmies. So we already learned in our social pygmies. They are very close to equator. Africa is very close to equator. So that's why especially Asian countries, especially in the Asian countries in India, we have very moderate temperatures, where we have very good rainfall, and we have three seasons. That's why we don't have a very high temperatures and we don't have very low temperatures. Our climate is moderate climate. So these are all the applications of specific heat. In the same manner, if you put a watermelon in the refrigerator, if you take out that watermelon out, it will take a lot of time to lose its coolness, because in the watermelon, most part of the watermelon is filled with water. I told you already. So temperature is nothing but hot. Coolness is also called temperature, cool temperature. Okay, that's why it takes a lot of time to lose its coolness. That's why specific heat, because specific heat of water is more. In the same manner, if you take samosa, stuffed the stuff of the stuff in the samosa take a lot of time to lose its temperature. It's because stuff have more specific heat. So all these are the applications for specific heat. So up to now we discussed about what is heat, definition of heat, units of heat. Okay, SI unit and CGS unit relation, and temperature. What is temperature? And definition of temperature, units of temperature, CGS units, SI units, Celsius, Kelvin, and Fahrenheit relation on that scales we discussed. After that, relation between temperature and absolute temperature and kinetic energy. Then after we discussed about specific heat. So then after we discussed about thermal equilibrium. So then specific heat derivation, specific heat formula, specific heat definition, and applications. Up to now we discussed it. After this we discussed about method of mixtures, principle of method of mixtures. Then after we discuss lab activity to find the specific heat of lead shots, very important. Then after we'll go to different topics, concepts like evaporation, boiling point, the melting point, freezing point, humidity, fog, all these things we are going to discuss. So for today, we are ending here. The next video, I will discuss the things which I told you now. Okay, thank you.